Okay, hello. So my name is Pam Fisher, and I have been involved in media technology for 20 or so years, and technology industry for longer. I work with the Media Institute, which is an academic industry research organisation based at University College London, but also that works internationally with a number of partners. Okay. So I've been involved with the IPTC Video Metadata Hub since the beginning 2 years ago when it was first proposed, and I'm very excited about this standard, and I'm pleased that it got the go-ahead yesterday, and it's a real thing now, so that's very good. But now we have to move on to the interesting part, which is actually making it real and moving on to implementation and adoption and so on, and that's kind of the tricky bit. Some of the interesting things about it are just the fact that it acknowledges other investments in standards making like PB Core, EBU Core, and so on. It's a hub, it's not an independent standard coming along. And also it represents this community, the IPTC community actually has the best adoption record of any standards body. I mean, everything else, you're lucky if the entire community that may adopt it gets to maybe 5%. Within IPTC, some of the previous standards, photo metadata, for example, got to a very high level of adoption. So that's why, again, it's important for IPTC to be doing this work. There are three areas I wanted to discuss. In particular, one is automated metadata extraction, because if we know we're going to have a lot of data now, we need to apply metadata to, so some tools would be useful for that. Cross-collection vocabularies, which I'm very pleased Rebecca's touched on, because PB Core has always been a good example of that, but time for an update. And also just open tools I wanted to talk about briefly. So I've said before, it's the metadata community is full of lots of vertical silos of different people doing different things, and it's for one of two reasons: either because of what content's being dealt with, or because of the purpose. I think there are really four main purposes for these standards. It's either because of workflow and interchange, moving things through a supply chain, and examples of that are interoperable master format, digital production partnership, which will probably become IMF eventually, NABA in the US, or asset management, PB Core, EBU Core, if like started in that place, and or systems operations, SIMPD, ISO MPEG. They tell computers and they tell systems what to do with content, and that's the main purpose of those standards. Or search and discovery. There have been several attempts. There are sort of the unique ID people, IDER, ISAN, and also say within Google Content ID, which attempts to uniquely identify things. Not terribly well, but good effort. And then different vertical silos. There are digital cinema standards that are only used within digital cinema. Different areas, and generally within all metadata standards, you can, to me, they all break down to one of three things. It's semantic data, rights data, or engineering and technical metadata, and that's what we have within IPTC as well. One thing I'm aware of is there are probably, we've always estimated there are over 200 million unique hours of professionally produced or professionally accessioned moving images in the world. I know that's a vast underestimate when you think of versions and instances and accessioned rushes and so on. Very, very big differences. If you think of one single Formula One race, you'll have 2,000 hours of media because there are cameras everywhere, 3 per car everywhere else, and other things that are just very unique. One feature film today might be 80 terabytes of data, and you end up with 90 minutes. So there are extremes within this, but generally within all that data, we think less than 10% of all the original data has been digitally mastered in some form. less than 5 to 21% is rights ready. The later number, the higher number is from a study that Screen Digest did with Focal in 2010. How many are added each year? Well, I say about 6 million more hours added each year. You know, who knows? Nobody knows. We know as well that video now dominates the internet. I mean, Cisco do something called Cisco Visual Networking Index because they have such a footprint with all the routers in the world. It's very easy for them to measure and report every year on how much of the content that's flowing through networks today is video. And right now it's in the over 60%. It's predicted to be much more if you exclude. Excuse me. I don't have a cold, but for some reason I still have the cough. Not contagious, I promise you all. But if you exclude BitTorrent and P2P video traffic, then that's where these numbers come from. And there's some interesting subsets within that. 19.7% of all digital ad spending is video. Virtual reality content has grown 4 times in 2015. It's going to grow 61 times by 2020. So there's some very interesting pockets of video growth in that. Excuse me. But overall, with the metadata coverage within all these vertical silos and all of this traffic is very minimal today, and we need to do something to make inroads into that. And one example I have to show you is just taking content from 3 sources on one particular documentary called Survival of the Sea Otter from 1973 or 1971, depending on who you believe, owned by either Rovi or ITV Global Entertainment. And the IDA record by Rovi says one thing. The materials database of ITV says something quite different. And the IMDb entry says something quite different again. So we just don't know, what this. I think the ITV entry is probably closer to the truth, but right now metadata is not great. When I mentioned 200 million hours at minimum unique hours in the world, well, within IDA, there's about 1 million hours represented, and some of those are instances and versions. So this is not a high number. I wanted to talk a bit about automated metadata extraction and just the. Oh, thank you. You'll all appreciate. I'm going to have a drink of water, and it'll be good for you too. One thing before talking about automated metadata extraction is just to say that this has been going on for a very long time. So within academia and within commercial companies. So just a couple of examples. The slide on the left here is from a presentation that Carnegie Mellon University, or a company called Islip, or a company called MediaSite, depending on what age you took that research group, did, looking at what they were extracting. They had something like 80,000 hours from CNN, and they did a study sort of looking at, what can we get out of this, and there was a lot of research. The one on the right is a study I sponsored out of the University of Bristol, and it was about how can you look at media, point your computer at media, and extract what SMPTE camera motion was going on, sort of in the heyday of MPEG-7. So this has been going on a long time. Today, things are finally getting to a state that they are commercially potentially very vibrant, and that's because of the technology has moved on. So lots of new technology in deep learning, convolutional neural networks and so on. And so long as, the thing with deep learning is that if you focus on any objective, you can probably solve that problem. So at lunchtime, some people were talking about language, speech to text and so on. Microsoft have really focused on that problem. They're getting somewhere. If you focus on a problem, you will get somewhere. So I think within this area, there's a lot of work right now going on in terms of looking at content and trying to find things out by pointing a computer at content, professional media content, and that's really going to help us to populate these databases with metadata. Excuse me. And what this does is it means that in contrast to things like Google's Content ID, which you can very easily fool by, say, filming something in a movie theatre and you have the seats, the outline of the seats in front of you, that won't recognise that you've just filmed Batman. It won't recognise it because they're the outlines of the seats. But with this, you can find things that are like a bit bent, a bit skewed, and also you can find things that are objects within bigger images. So if you wanted to find a bouquet of flowers in a frame, in a sequence, then that's all sort of happening as well. So this is technology that's moving forward incredibly quickly. Why do we need this? We need this for a few reasons. One is we want to find out what things are. The reason you film something is not often the reason you license it later. So getting a computer to extract metadata is pretty interesting. There's one thing I wanted to mention, which was that it's a great source of ground truth for all the researchers involved in this area. And it's something called ImageNet. And it's a collaboration between Stanford and UPenn, I think, is the other one. But there's a wonderful TED Talk. If you have 10 minutes to spare, I highly recommend it by one of the key researchers, Li Feifei, talking about how they did this. They basically took 14 million images, had many humans annotate them, and now there is ground truth that researchers have access to. It's all open source stuff, so it's pretty useful. So if you want to find cats, and cats don't always look like you expect them to, or beaches, there are some things from ImageNet. Another reason we need this is anti-piracy. Here are a couple of real video covers you can buy. It's obviously Break So Bad is not something that I don't think really came out. But if you can uniquely identify content, then you know you can. It's great for anti-piracy. And deduplication of file systems. How many of us have terabytes of stuff, and we just don't know. Obviously, you can set the policy and say, well, I'm going to digitize this once in well, and then reissue the content periodically as standards change, as codecs changes, as more visual quality can be extracted from this original. But people are frightened to throw away past work. So deduplication is quite important with moving images. Being able to do visual quality analysis. If you have 20 instances of something, which ones do you need? We did a study within BAFTA a couple of years ago looking at, for the Film and Television Awards at BAFTA, looking at what happens if broadcasters will submit their content and for awards. It's then transcoded in 4 different ways to be streamed out for people, to the jurors and the professionals' view. We found that one 800K version was visually identical to a 1.5 megabit version. Throw away the big one. Don't need it. No reason. So it's good to be able to do that. And then a lot of this technology as well displaces the earlier fingerprinting technology. It's quite horrible to use in some cases. And just to mention about visual quality as well. There's some bad visual quality out there, and I see interlace sometimes. I still see interlace sometimes on why am I seeing interlace on the internet? This is not good. We know better than this these days, but not always, obviously. So I wanted to also talk about cross-collection vocabularies, because often the goal in metadata is to be able to search beyond a single collection and be able to say, well, who out there has something where I need I need leopards chasing lions in Africa, not lions and leopards. I need leopards chasing lions. How are you going to find that? How do you know who has that? Right now, what you do is you give a researcher some money and a bunch of time, so much time that it can't possibly be used in right now media. It only can be done in a documentary. It's hard. So having vocabularies makes things. We need to aim for simplicity and things that are easy to adopt. Just one example in coding formats. If you look at video codecs, if you look at the current 2011 PP Core example, there are 243 different codec descriptions. Lots of them very inaccurate, actually, and even then, very inaccurate. So I'm very much looking forward to that particular one. And if you look at Netflix and their IMF standard, there are 2 codecs you can have, only 2. And that's kind of underestimating what really goes on, but there we go. So we need to get these vocabularies so we can, just honestly say which coding format we're looking at. There's a lot of growth and complexity that we have to represent in these. One is with color space. There's been a lot of research and lots of advances in color space for recent years. People are aware of Rec 2020, the next stage of 4K TV, whatever, high dynamic range content, ACES, which is more of a feature film format, which draws a triangle around every possible point in a color diagram and says, you know what, we're just going to draw a circle around everything. That's ACES. Just, I don't care if humans can see it or not. We'll just put it there. But it means that it's very complex now, representing color. The object-based media, we have new W3C standards. Somebody mentioned earlier about publishing. The media source extensions, encrypted media extensions. These are going to displace, they follow on from things like MPEG-Dash, but they're going to displace a lot of the proprietary standards for adaptive streaming and so on, and allows things to be integrative to the desktop so that you can put together a media composition and draw from many sources and integrate to the desktop. And that's, again, how things like IMF are designed to work as well, interoperable master formats that only show the things that are different. So take the Disney film Inside Out, which you've probably seen in Europe and the US. The disgust character hates broccoli and gets very disgusted at broccoli. Well, in Japan, children love broccoli. And so that's actually green peppers in Japan. And with IMF, Disney can deliver one package and everyone gets it and follows on. Also, timed text. Timed text is moving very, very quickly, and I think partly energized by Netflix being very aggressive in it. And this is aimed to replace a lot of the overlay text in the lower third of content, not bake it in and render it, but make sure that can be multi-language and come as timed text, be a standard, which is formatted and so on. Production formats and profiles. We did have a lot of proprietariness until very recently, but today even GoPro, Cineform, and Apple ProRes are SMPTE standards now, and open, and anyone can read from and write to. The other thing that's going to be needed in this area, one of the things we're actually trying to assemble and do more work on in the Media Institute is open tool sets. I think a lot of people have their own in-house IT groups are more proficient than DAM vendors in supporting their needs. They've had a lot of experience in it and they do a good job. So we want to make sure there are a lot of open tool sets that are available for people to use and that people know about them when they exist. So one example is in the UK comprehensively, but also beginning to be in Europe. If you're doing broadcast contribution, if you're a production company and you're giving a television show to a broadcaster to broadcast, you must use something called DPP format. In the US, it's IMF format, which interoperable master format, which paradoxically isn't about masters at all, but about delivery of content. Lots of the new streaming entities are global and can't be dealing with individual countries' needs. So Netflix have done a tool to do IMF DPP mapping. It's open source, anyone can download and use it, integrated into your asset management system. With the metadata, fill in a spreadsheet and, hey presto, the metadata is there. So I think we're coming into the exciting stage now, and I'm looking forward to contributing to the work of making these things real and make them make it possible to adopt through the vocabulary, through open tool sets, and so on. And I think what we're going to need as well is we're going to need some genuine experiments from people with real content to show how is the standard playing out, is it useful, who wants to do what.
Perfect. Thank you very much, Pam.